Okay, so I'm going to tie factoring into multiplication. So going back to just basic numbers, if you have a number like 3 and you're multiplying it by 4, the 3 and the 4 are called factors. When you multiply them together and get 12, you get a product. So understanding number one, the difference between factors and a product is important. So in that first example, example A in your notes, you have 3n and then in parentheses 2n plus 7. Is it a plus 7? I think so. All right. So the 3n is a factor. The 2n plus 7 is a factor. The 3n is a monomial factor because it's only one term. The 2n plus 7 is a binomial factor because it's two terms. But again, these are factors. When you are simplifying, you are basically multiplying each factor together. Well, when you have a monomial factor times a binomial factor, that monomial factor needs to be multiplied to both or all terms inside the parentheses. So you have to multiply the 3n times the 2n, plus you're multiplying the 3n times the 7. When you are multiplying, these do not need to be like terms. Only when you're adding or subtracting do you have to have like terms. So when you're multiplying, the coefficients get multiplied together. So the 3 times the 2 would be 6, but then your variables, the exponents, get added. So if there is no exponent, it's automatically an exponent of 1. So n to the first times another n to the first, when you add the exponents, becomes n to the second. And then the 3n times the 7 is 21n. And as far as signs go, it's just a plus. Please be very careful with your signs. Now, this first example was just positive, so there really isn't a whole lot of difference with your signs. But this is now the product. So there's that difference between the factors and the product. So now we're going to go the reverse order. So if you started, say, with 12, and you were asked to factor 12, there are different ways that you can factor it. But factoring in algebra is similar to factoring a number into its prime factors. So we could factor the 12 into 3 times 4 like we started with here. So the 3 and the 4 are factors of 12. But the 4 can be factored again into 2 times 2. And then, but the 3 cannot. So the prime factors of 12 are 3 times 2 times 2. So that's factored completely. So when we, now looking at example B in your notes, when you're asked to factor a product, 8x squared minus 100x, if it is more than one term, then you need to find two things. You need to ask yourself, number one, what is the largest number? So we're trying to look for what we call the greatest common factor. So the greatest common factor, to figure that out, you basically ask yourself, what is the largest number you can divide both terms by? So if you look at your 8 and your 100, what is the largest number we could divide both 8 and 100 by? Samantha, what can we divide both 8 and 100 by? Take a guess. Alexis? 4. Good. We could also divide by 2, but is 2 the largest? So 4 would be the largest number we can divide both of those by. So we would say 4 is the greatest common factor as far as numbers go. But then you also have to ask yourself, what about the variable? So if you look at both terms, they both have an x. But the second term only has an x to the first. So you can only factor out, so the greatest common factor between x squared and x to the first is actually x to the first, because you cannot factor out more than something has. You can't divide x to the first by x squared, or else it's going to be a fraction. So 4x to the first then is the greatest common factor. So watch the way I set this up. So the 4x, since that's your greatest common factor, is going to go on the outside. But then you have to, on the inside, divide each of these terms by 4x. So if you multiply by 4x and divide by 4x, are you really changing the value of the original expression? So just like if you were to multiply, say you have a 3 over here. If I multiply by 4 and then divide by 4, will I get a different number than 3 than I started with? No, it's going to be the same thing. So this is basically what we're doing here. We're putting the 4x on the outside because that's our greatest common factor, but then we're going to divide. We have to divide each of these terms by 4x in order to make this equivalent to what we started with. So your expression here should always equal what you started with. Now, eventually, I'm not even going to do this part here. I'm going to just, in my head, divide both of these terms by 4x and put the two terms that we have left over in the parentheses. But I like to show that so that you can see where the two terms are coming from. So the 4x is now one of the factors of this polynomial. And then if I divide 8x squared by 4x, I get 2x. And then minus, if I divide 100 by 4, I get 25. But what happens to the x's here? Will there be any x's left? Anything divided by itself reduces, right? So the x's would go away. There wouldn't be any more x's there. So then we end up with 2x minus 25. So this is now factored, where the original is the product. Is there anything else? So the last thing you should ask yourself, is there anything else I could do to factor this 2x minus 25? Can you divide 2 and 25 by anything bigger than 1? Oh, any integers, I should say, bigger than 1. So the answer would be no. So we know that we have this factored completely. Now, how can we check to see if our factoring is correct? You can always multiply it back together. Now, I would suggest that you do this mentally, not physically, not actually write it down, but or you can do this on a separate sheet of paper. But if you multiplied the 4x times the 2x, you would get 8x squared, right? And then if you multiplied the 4x times the 25, you would get a negative 100x that you started with. All right, hold on a second. Is that the same number thing you had in your B? Okay. For some reason, I was thinking I made a change to your problem. All right. Any questions so far? Good morning. Welcome. Thank you. So in those notes, we finished examples A and B. Okay. Actually, I'm going to pull up the notes on here. So that's a little bit easier for you guys to follow, and then I know that I'm doing the same problems as you have. All right, so we are now on example C. So in example C, it's very similar to example A, but instead of having a monomial with a variable, we just have a number. But still it's a monomial times a trinomial. So we have three terms now that we have to distribute the negative 2 to. So when we are multiplying this together, you must distribute, which is the same, or multiply. Oops. The negative 2 to all terms. So that's very important. Some students will forget, they multiply the first one and then they forget the other two. But this negative 2 has to be multiplied or distributed to all of the terms in the parentheses. So if we take negative 2 times x squared plus negative 2 times 5x plus negative 2 times negative 6. So we're distributing that negative 2 to all three terms. Now, eventually, we are not going to probably do this step here, but it does kind of help you to see what exactly is going on. So the negative 2 times the x squared would be negative 2x squared. I don't know why this is giving me such problems today. And then the negative 2 times the 5x is a negative 10x. So be careful with your signs when you are applying negatives. That's the number one mistake the students make, are the signs. And then the negative 2 times a negative 6 is going to be positive 12. So plus 12. Okay. All right. So that is simplifying or multiplying. And it seems very simple, but as soon as you start putting these type of problems together, or you're taking an I-STEP or SAT, and you see the word simplify in the directions versus the word factor, you have to understand the difference between those two things. All right, so when you're given something like this, these are factors. This and this are factors. The negative 2 and the trinomial x squared plus 5x minus 6 are factors. This is the product. All right, so now in example D, you are given a product. And you have to figure out, well, what could I factor out of all these three things? Now, this particular example, I made it so that there is a negative leading coefficient. Another thing that I should probably mention is when you are factoring, it's always a good idea to put your terms in the right order, which basically means if you're looking at your variable, your highest exponent, the variable with the term that has the variable with the highest exponent should go first. This is called standard form. So standard form, your variable that has the highest exponent should go first. Then descending from there down to the constant, which has no variable at all. All right. So number one, make sure it's in the right order or standard form. But then when you have a something that has a negative leading coefficient, you don't just factor out. So we're going to make a little note here. Never leave the leading coefficient negative when factoring. So if we look at 9, 12, and 6 without the signs, if we just ignore the signs just for a second, 9, 12, and 6, what is the largest number we can divide all three of those numbers by? Let's see who am I at? Michaela. What? 1? Oh, what is the largest number we can divide all three of those numbers by? The 9, the 12, and the 6. 3. Good. But instead of factoring out just 3, because our leading coefficient is negative, we're going to actually factor out negative 3. So don't just factor out 3. Oh my goodness, this is driving me crazy. Factor out negative 3. Okay, so that means I'm going to put a negative 3 on the outside, and that means I'm going to divide all of these terms by a negative 3. So again, if you're multiplying and dividing, this is still equivalent to what you started with. So the negative 3 will stay on the outside. And again, eventually this step here we're going to do in our heads. But for right now, I would like for you to at least show it in the notes so you know where this is coming from. So when you divide a negative 9 by a negative 3, no longer is that going to be negative. We're now going to have a positive 3n squared. Oh, as far as the variable goes, we forgot to look at the variable. 2 of these terms in the original expression have a variable. The third one does not. You can only factor out the variable if all the terms, all 3 of them, have that same variable. Since the 6 does not have a variable, then we cannot factor out an n from any of the terms. So that's why the n squared and the n are going to stay the same. All right, my next term, the 12n divided by negative 3 will then leave me with negative 4n. And then the negative 6 divided by the negative 3 will be now a positive 2. So when you factor out a negative, notice that the signs that you originally had were negative, positive, negative. Well, now it's positive, negative, positive. So the signs of those terms, when we divide by a negative, will change because that negative went on the outside. So always factor out a negative if your leading coefficient is negative. Sometimes it's just a negative 1. And we're going to have an example like that in a minute. Okay. So now we're going to get to, so that's greatest common factor, factoring out a greatest common factor. The next type of, so that is one of the most common types of factoring that we do, but the next most common type of factoring that we do is factoring out trinomials into 2 binomials. So we're going to start by multiplying the 2 binomial factors together so you can see what that looks like. So these are called basic trinomials. Thank you. So a basic trinomial is basically a trinomial that has, or a polynomial that has 3 terms like this x squared plus 12x plus 27. And the a value equals 1. So when we were graphing quadratic functions, we talked about a, b, and c. So this is in standard form. Your a value is 1. Your b value is 12. Your c value is 27. So when you have a basic trinomial, your a value is 1. and you will factor a whole lot of basic trinomials in your mathematical life in the next couple of years. So let's learn it well. But let's figure out where that trinomial comes from in the first place. So a binomial times a binomial. These are binomial factors. So when you multiply a binomial times a binomial, you have to distribute every term to every other term in the other binomial. So the k in here, in the first term, has to be multiplied by the k here in the other binomial. And I'm going to put a little f there because that's basically representing our first terms. So you're going to multiply your first terms together. So there's an acronym that we use called FOIL. Hopefully you are familiar with that a little bit, but F stands for the first terms in each binomial. O stands for the outside terms in each binomial. I stands for the inside terms in each binomial, and L represents the last terms in each binomial. When you multiply a binomial times a binomial, you will originally have 4 terms, but then it's going to usually condense to 3 terms when you combine your like terms in the middle. All right, so your first terms multiplied together, k times k. On the outside, so k is on the outside here, 8 is on the outside there. Let me change my colors up a little bit. So if I do k and 8, that's your outside terms. Okay, so let's talk about the outside terms. So your outside terms, k and 8. So if you're multiplying the k times the 8, you're going to get 8k.
Make that plus 29 as well.
And then k times k is k squared, because again, when you're multiplying variables together, you add the exponents. All right, moving on to the inside terms. So the 7 and the k are the inside terms. So the 7 from the first binomial and the k from the second binomial are your inside terms. So if we multiply the 7 times the k, we get 7k. And then our last terms, the 7 is the last term in this binomial. The 8 is the last term in this binomial. And that will equal 56. All right, so then once you get the first, once you multiply the first terms, outside terms, inside terms, and last terms together, the middle terms are like terms. So then you need to combine your like terms. So when I combine my like terms, I get 15k, but the k squared does not change. These are both positive. So it's a positive 15. This is a positive 56. And we get our trinomial, which is our product. So that usually is pretty easy for most students to follow, and you've done this before. Hopefully it's not new to you and you recognize doing that. But the factoring is where we sometimes run into problems. So let me now show you how to factor from a trinomial back to the binomial factors. So in order to do that, it helps to kind of understand where the numbers came from. So if this is so if you're given this trinomial and you had to factor it. So I'm going to go back over here in my white screen. Where did we get the 56 from in the first place? By multiplying the 8 and the 7, or the 7 times the 8. Where did we get the 15 from in the first place? By adding the 8 and the 7, or 7 plus 8. Doesn't really matter which one you say first. So when you are factoring a trinomial, a basic trinomial that has an a value of 1, you're looking for two numbers that will multiply together to equal c, which is your constant, and add up to the middle term, the coefficient of your middle term, 15. So these two numbers have to be the same two numbers. So they have to multiply together to equal this, but they also have to add up to this. So that's where those numbers come from. So if we are given x squared plus 12x plus 27, we have to, in our minds, ask a question. So we're going to write out the question that we're going to ask, because this is mental. A lot of factoring is mental. So you have to know what to ask yourself. So the question is, what two numbers multiply to equal the constant c, 27? That's your c value. And add up to your b value, which is 12. All right, so I started with a couple numbers that hopefully are easy to work with, but just in case you can't think of the two numbers that will multiply together to equal 27 and add up to 12, if you don't know your multiplication tables really well, or maybe the c value is in the hundreds and you can't figure out what two numbers these are, my suggestion is to make a list of the factors of 27, maybe off to the side, starting with 1. So plan B is always to list your factors of your C value. So if we list the factors of our C value, which is 27, starting with 1 times itself, 27. Don't forget that 1 and the number itself are factors of that number to begin with. 2 does not go, then you would go to 2. Can you divide 27 by 2 evenly? No, but it does. 3 goes into it 9 times. And those are the only factors of 27. So the two factors that multiply together to equal 27, but also add up to 12, are your 3 and your 9. Okay, so we are going to basically factor this in one step. This shouldn't take, the goal for you by the end of this lesson is to be able to look at a trinomial factor like this and be able to factor it in like 30 seconds or less. This should not be a hard process. It should be very quick and easy. Just like multiplication tables, factoring is a skill that you're going to use a lot. And when you get into integrated 3B, if you don't have this skill down, you will probably not pass 3B either. So factoring is, like I said, the number one reason why students don't pass this course. All right, so going back to the previous example, this trinomial, if we factored it, would factor into k plus 7 and k plus 8. The k that we had in the beginning comes from that k is multiplied together to equal that k squared. And then the 56 came from multiplying the 7 and the 8 together. The middle term comes from the outside and the inside. So the outside was 5 or 8K, the inside was 7K, which together gave us that 15K. Well, we're basically doing the opposite. We're starting with a trinomial and we are factoring it into binomial factors. So how could we get the first term to be an x squared? Well, what would we have to multiply here and here together to get x squared in the first place? What would have to be in those blanks? What times what would equal x squared? X. X times x is x squared. Just like over here, where did the k squared come from? By multiplying k times k. All right, we're going to talk about signs in a little bit, but the two numbers that we just found, the 3 and the 9, are the numbers that are going to go here. And it doesn't matter if you put the 9 first, then the 3, or the 3 and then the 9. Just like when you multiply 3 times 9 and 9 times 3, it's still the same thing. Now, as far as signs go, in order for this 27 to be positive, your signs have to be the same. Because a positive times a positive is a positive, a negative and a negative multiplied together is a positive. So as long as the signs are the same here and here, you will get a positive C value. But in order for them to add up to a positive 12, they have to both be positive. So we just factored this trinomial into two binomial factors. And again, a lot of this is mental. Setting up the two binomials, x squared factors into x and x, two numbers that multiply together to equal 27 that add up to 12, 3 and 9. The signs are the same. They both have to be positive, plus and plus. So if we were to multiply this back together, it would equal what we started with, because x times x would be x squared. If we multiplied our outside terms together, we would get 9x. If we multiplied our inside terms together, we would get 3x, which adds up to that 12x that we have in the middle. And then if we multiply the last terms together, 3 times 9 gives us 27. Okay, so do you guys remember doing these? Kind of, sort of, hopefully. All right, the next example has two negatives. So both factors, that we do have two binomial factors again, but there are minus signs in between them. So the p times the p, those are your first terms. Will be p squared. Then if you multiply your outside terms, so the p is on the outside of this binomial, the -9 is on the outside of, so the sign that's in front of it has to go with it. That's another important fact. So we're taking p times a -9 on the outside, which will be -9p, because a positive times a negative is a negative. And then we are going to multiply the inside terms together. So the -6 and the p are on the inside. So again, take that sign that's in front of it. -6 times p is -6p. And then the last term, so the -6 and the -9 are the last terms in each binomial. So if we multiply -6 times -9, again, you're using the sign that's in front of it. Negative times negative is a positive 54. And then in the middle, you now have like terms. So the negative 9 and the negative 6 added together is negative 15p. This p squared stays the same. The 2054 does not have any like terms, so it does not change. So now this is your trinomial product, where we started with binomial factors. So again, let's think, where does the 54 come from? From multiplying these two numbers together. Negative times negative is a positive. Where does the negative 15 come from? By adding these two numbers together. So negative 6 times negative 9 gives us the 54. Negative 6 plus negative 9 gives us the 15. So they're the same two numbers, but multiplied to give us our C, added up gives us our B. So now let's use that same concept for going from the trinomial to the two binomials. All right, so step number 1, we're going to set it up. So our setup, as long as your A value is 1, and this can be factored. So not all trinomials like this can be factored, but the ones that you're going to be doing today and for a while, they will be. A lot of them that you see throughout algebra are factorable. So this will most likely factor into two binomials. So there's going to be a term here and here, a term here and here. The first terms have to multiply together to equal the first term there. So if your first term is r squared, what does the first term have to be in each binomial? Let's see, who are we going to pick on now? Levante, what does the first term have to be in each binomial? R. Thank you. All right, so now the last terms have to multiply together to equal 42, but they have to add up to 7. So one thing that I am going to introduce you to is an X, like using this, it's called on the Delta Math program that you're going to be doing your assignment on, it's called the X game, but it's basically just a strategy for finding your two numbers. So the question is, what two numbers multiply to equal 42, positive 42? We'll throw the signs in now, which is your C value and add up to negative 17, and that negative 17 is your B value. So if you use this as this X game thing as a strategy, put the C value at the top, put the B value at the bottom. Oops, not 12, 17. And then you're trying to find the two numbers here and here. So two numbers that multiply together equal 2 that add up to 17. Let's ignore the sign just for a second. Two numbers that multiply together equal 42 that add up to 17. Well, a lot of you are probably thinking 6 and 7, but 6 and 7 do not add up to 17, do they? They add up to 13. So we may have to make a list. So if you list your factors of 42, that might be helpful, starting with 1 and 42. So if you can't think of your two numbers, plan B, make a list. Then go to 2. Can you divide 42 by 2? Yes, it's even. And you get 21. 3, then go to 3. Start with 1, then go to 2, then go to 3. Can you divide 42 by 3? Actually, yes. You get 14. It cannot be divided by 4 or 5, but it can be divided by 6, which gives you 7. So these are all the factors of 42. So now let's ask the question again. What two numbers multiply together to equal 42, but also add up to 17? 3 and 4. But we don't want, or 3 and 14, sorry. But we don't want them just to add up to positive 17. We want them to add up to negative 17. So if they're both negative, they will add up to negative 17, but they will also still multiply together to equal a positive 42. So the negative 3 and the negative 14 are the two numbers that we're going to put in our binomials. So that's where we get the two numbers from. And that's kind of the hardest part. And a lot of this, like I said, is mental. Okay, so what do we notice about the signs in the binomials? Again, our C value was positive. So in our binomials, are these signs the same or different? So they're going to be the same, because a negative times a negative is a positive, just like a positive times a positive is a positive. However, they have to both be negative in order for them to add up to a negative 17. Where if you look at the last example, your C was positive, which means the signs in your binomials are the same. But in order for them to add up to a positive 12 in the middle, they have to both be positive. So notice these sign patterns. We're going to write these down later on as well. But as we work through these, it's helpful to recognize them as we go through the process. Okay. Now we've got different sign pattern.
Excuse this interruption. Bus 52 has just arrived. Thank you.
All right, so we're going to start again with the multiplying. If I take my first term here times my first term there, I'll get W squared. If I take my first term, or my outside terms, the W and the negative 4, I get negative 4W. If I take my inside terms and multiply them together, 12 times W is just 12W. And then if I take my last terms to multiply, so 12 times the negative 4, I get a negative 48. So the W squared does not have any like terms, but these two are like terms, negative 4 plus 12. Yes, we are adding negative 4 and positive 12 together, but when you add things with different signs, do you actually add 4 and 12 or do you subtract? So when your signs are different, you are basically subtracting 12 minus 4 and getting 8. And then the sign of that 8 is going to be the sign of whatever number was larger. So if the 12, which is positive, is larger than the 4, which is negative, then your 8 will be positive. However, if it was a positive 4 and a negative 12, then you would get a negative 8. Again, the signs are different, so you would subtract 12 minus 4, which would be 8, but because the 12 is negative and that's the bigger number, then this would be a negative 8. Just saying. So just a quick review of adding and subtracting, or adding like or positive and negative numbers together. Now, your 12 and negative 48, when you multiply a positive and negative together, you get a negative. So this is now our trinomial product. And these were our binomial factors. All right, so again, where does this 48 come from? From multiplying the positive 12 and the negative 4 together. Where does this positive 8 come from? From adding the 12 and the negative 4 together. So these are the same numbers, but when you multiply them, you get negative 48. When you add them, you get that positive 8. So the signs are different when your sign here is negative. So when your C is a negative number, your signs have to be different. But the larger one is going to go with that B value. So that's another rule thing that we kind of talk about. All right, so now let's factor one that's similar. So the setup is going to be the same. So first of all, recognize that it is a trinomial with an A value of 1. When you have a trinomial with an A value of 1, it's called a basic trinomial. And we're going to factor this in one step in less than 30 seconds. That's your goal when you do these. So set it up so that you have room for 2 terms in each parentheses. Again, the first term here times the first term here has to equal the first term there. So if this is g squared, then this has to be g times g. To figure out the numbers, write down the question. What 2 numbers multiply to equal a negative 63 and add up to a positive 2? So when you have a negative here, this gets a little bit more complicated. So I'm going to help you with that a little bit. So your C is negative 63, your B is a positive 2. So your signs, if this is a negative number, and these 2 numbers have to multiply together to equal a negative, will the signs of these 2 numbers be the same or different? Are they going to be the same like the examples prior to the last page? No. In order for 2 numbers to multiply together to equal a negative, your signs must be different. One's going to be negative, or one's going to be positive, one's going to be negative. It doesn't matter which one you put first. Because the signs are different, in your head, rather than thinking of 2 numbers that add up to 2, think of 2 numbers that have a difference of 2. So if the signs are different, think difference. What 2 numbers multiply together equals 63 but have a difference of 2 or would subtract to equal 2? What would those 2 numbers be? Again, if you can't think of it, list your factors of 63. 1 and 63. 2 does not go into it. 3 goes into it 21 times. 4 does not go into it. 5 does not. 6 does not. 7 goes into it 9 times. So now that you have all the factors listed, which pair has a difference of 2? 7 and 9. So we know there's going to be a 7 and a 9 here and here. But if we want them to add up to a positive 2, the larger number has to be positive. So the 9 has to be positive, the 7 has to be negative. Now let's think about that. Will a positive 9 times a negative 7 equal a negative 63? Yes. If I add positive 9 and negative 7 together, do I get a positive 2? Yes. So then my two numbers here and here in my answer are positive 9 and negative 7. So all this stuff right here is mental. Now, yes, you can write down some stuff on the side that does help when you have a strategy, but you should be able to do this in less than 30 seconds. Okay, so we only have 4 minutes left. I'm going to go ahead and pause there. There is an assignment in Delta Math today. So your assignment is in Delta Math. And when you log in to Delta Math, you log in with your school Google account. Okay, so I believe, has everybody in here used Delta Math? We used it when we were doing the transformations. So it should be there.